We are going to continue a discussion with respect to the simple linear regression. And in our previous video, we have already seen what is our main aim, and we have understood about the notation. And we also found out that, okay, let's try to find out an optimized way to actually get the best fit line. Okay. Now for this, we will be using a cost function. Now here I'm just going to mention about this specific cost function. And this cost function is basically given by a notation. Let's consider this specific notation. J theta 0 comma theta 1 is nothing but 1 by 2m summation of I is equal to 1 to m h theta of x of I minus y of I whole square. Now what is h theta of x of I minus y of I whole square? As I said that we have to make sure that we have to create a best fit line in such a way that when we do the summation of all the specific errors, it should be minimal. So that is the reason we are taking up this cost function in this specific way. H theta of x of I is nothing but these are my predicted points, right? These are my predicted points and these are my truth points. So basically the true output, right? And I'm going to do the summation, which basically do this, when we do the subtraction, we basically get the error value. And the reason we are squaring it because the technique, the cost function that we are using this, we basically say this cost function as mean squared error, okay? Mean squared error. And there are a lot of advantages of using mean squared error, which we will probably discuss as we go ahead. Now you may be thinking, Krish, is there different kind of cost function also used? Yes, absolutely. You also have something called as mean absolute error, root mean squared error. We will all try to discuss about all this kind of cost function and what is the advantage and disadvantage with respect to that. Okay. But here right now, the reason I'm taking up this cost function because we really need to minimize this cost function. And we need to minimize in such a way by changing the theta 0 and theta 1 value. Theta 0 basically tells us about the intercept and theta 1 basically talks about the slope. Okay. So what is our final aim? I'm just going to write out final aim, what we need to solve. Okay. What we need to solve. This is super important. Then only here I basically use the cost function. So our main aim is basically to minimize the cost function j theta 0 comma theta 1, which is basically denoted by this specific equation, that is 1 by 2m summation of I is equal to 1 to m h theta of x of I minus y of I, okay, whole square. Okay. Since we are dividing by m, so we are getting this as mean, right? Mean squared error. We basically say this cost function as mean squared error. And how we are going to minimize this? By changing the value of theta 0 and theta 1. So we really need to continuously change this theta 0 and theta 1 and try to find out the best fit line wherein we do the summation of this particular error, and this should be minimal. Okay, minimal as possible. Okay, so this is what is our final aim that we are looking at. Okay, and how we are going to do this, let's try to discuss about it. Now I hope everybody knows what is the equation of my straight line. This is nothing but h theta of x, theta 0 plus theta 1 into x. So that basically means if I probably consider this, okay, the best fit line, whatever straight line I'm actually getting, let's consider that I'm getting this specific straight fit line. So this line is basically indicated by this equation. Now one important thing, guys, since there are two variables, right, theta 0 and theta 1, let's consider that theta 0 is 0. Okay, let's consider. There is a reason why I'm saying, because I really wanted to show you everything by drawing it in a 2D diagram. So let's consider theta 0 is equal to 0. If I say theta 0 is equal to 0, that basically means when my x value is 0, it is basically passing through the origin, right? This line is basically passing through the origin. So this intercept is exactly 0. Okay. So now my equation becomes h theta of x is equal to theta 1 multiplied by x. Let's consider that what I am doing over here, my intercept is basically passing through the origin. I'm just considering it so that I can draw a cool 2D diagrams to make you understand more in depth. So currently I'm going to just use this specific equation. Okay. Now let's consider some of the data points. Let's say this is my x and y. I'm just going to write 1, 1, 2, 2, and 3, 3. Okay, let's consider that this is my entire data set. And for this particular data set, I really need to create a best fit line, because this will give you a clear idea that what we are trying to do. So what we will do, we will just try to create this line like this. Okay, this is my X, this is my Y. So let me create it a little bit straight so that it looks cooler and good. So this is my X and this is my X and this is my Y. Let's say these are my values like 1, 2, 3, and with respect to X, Y also I have 1, 2, and 3. Okay, now let's start. Okay, and obviously everybody knows what is the equation. It is nothing but h theta of x is equal to theta 1 multiplied by x. Why? Because theta 0 is equal to 0, because we are considering it passes through the origin. Okay, so I have my data points. My data points are 1 comma 1, 2 comma 2, 3 comma 3. So let's go ahead and plot it. Okay, so here is 1 comma 1, then this is 2 comma 2, and this is basically 3 comma 3. Okay, now if I have this particular data points, I am going to use this equation of a straight line to make sure that I plot my best fit line. Okay, now let's consider, we need to initialize theta 1, right, with something. So let's consider, let theta 1 is equal to 1, because this is my slope, right? And we have to initialize the slope, and later on we will keep on changing the slope to get the different best fit line. So if theta 1 is equal to 1, then when x is 1, what will be my h theta of x? So my h theta of x will be actually 1 when my x is equal to 1, right? I hope this is very much clear, right? So let me just put this points, then this will be basically my predicted points over here with respect to h theta of x. Now when x is equal to 2, what will be my theta h theta of x? Now h theta of x will be, since I have initialized theta 1 as 1, when x is equal to 2, that basically means h theta of x will be 2. So my second point will be somewhere here, right? The predicted point, h theta of x, okay? And similarly, when my x is equal to 3, when theta 1 is equal to 1, that is my slope is equal to 1, then h theta of x is equal to 3, because 3 multiplied by 1 is nothing but 3. So my third point is somewhere here. Now, if I try to create a best fit line, so this is going to pass through all these points, right? All these points. So it is going to exactly pass through all these points. And obviously, it will also pass through the origin. Okay. So in short, these are my predicted points. And over here, I also have my truth points, right? I also have my truth points. Now let's go ahead and apply this cost function, j of theta, theta 1. This is this entire equation. So what is my cost function over here? My cost function is very simple. I will write j theta 1, because theta 0 is 0, right? It is passing through the origin. So I will write 1 by 2m summation of I is equal to 1 to m. And here I will basically say h theta of x of I minus y of I whole square, right? So how many points I have totally? I have 3 points, right? In my data set, I have 3 points, 1, 2, 3. So I'm just going to basically write 1 by 2 multiplied by 3. And I'm just going to basically say summation of I is equal to 1 to 3. Okay, so it will be the entire summation of 1 to 3, right? So no need to write 1 to 3. So I will start expanding this. So first thing is what? What is h theta of x of I when I is equal to 1? So over here you can see when I is equal to 1, h theta of x of I, the predicted point is also 1, right? So I'm just going to basically write 1 minus. What is y of I at that point of time? So y of I is also 1. And here also we have plotted it. So 1 minus 1 whole square. Okay. Then plus, we'll go to I is equal to 2. I is equal to 2. Over here you can see when the x value is 2, h theta of x of I is also 2 and y is also 2, right? So over here I'm going to write 2 minus 2 whole square. And similarly this is 3 minus 3 whole square. Okay. So overall, if I try to find out, it is 0. So what does this basically indicate? My cost function is 0. This is absolutely right? Because obviously there is no error. Exactly, the best fit line passes through all the points, right? Now this is one way. Okay. Now let's go ahead and consider, and let's change our theta 1 value. Let's say that our theta 1 value is now, let's consider that our theta 1 value, let's say our theta 1 value is 0.5. Now if it is 0.5, then what will be h theta of x when if x is equal to 1? So it will be nothing but theta 1 is 0.5, 0.5 multiplied by 1, right? So this is going to be 0.5, right? So when x is 1, so my h theta of x will be 0.5. So let me just denote this particular point over here. It is be 0.5. Okay. Now similarly, when theta 1 is point, and if x is equal to 2, then here you will be seeing h theta of x will be 1, because here we are just multiplying theta 1. Theta 1 is nothing but 1. Okay, 1 multiplied by 2. Sorry, 1 multiplied by, theta 1 is 0.5. So in this equation, h theta of x, theta 1 x, right? 0.5 multiplied by 2 is nothing but 1. Then h theta of x is equal to, when x is equal to 3, this is going to be 1.5. Okay. So when your x is 2, I'm actually getting 1. So I'm going to basically note this particular point. And when x is equal to 3, h theta of x is nothing but 1.5, which is basically mentioned at this particular point. Okay. Now here you will be able to see that I am just going to draw this next best fit point. So I'll make it a little bit better so that the point is basically drawn. So this is my best fit line for the next one. Again, sorry. So 3, 5. Okay, now this time I should be getting a best fit line. Okay, so this is my best fit line. Okay, now here you should be able to understand that these are my predicted points. This are my predicted points. Okay, now with respect to this, again, let's go ahead and calculate j theta. Okay, j theta of 1. So here I'm basically going to write what is j theta of 1. J theta of 1 is nothing but 1 by 2m. Again, I'll apply the same formula. So this will be 1 multiplied by 2, 1 divided by 2 by 3. And now let's go ahead and try to find out. So when my theta 1 is 0.5, or let me write it down below. Okay, so that you will not miss anything. Okay. So for the first case, let's consider, I have also drawn this specific point, and let me draw one more amazing graph. Okay, and this graph will be mentioning something very important. So let's create one more graph over here, and we'll continue with respect to different values. This graph is between theta 1 and j of theta 1. Okay, and let me denote it some points like this: 0.5, this is basically 1, 1.5, 2.0, 2.5, right? And similarly, this is 0.5, 1.0, okay, and this is 1.5, and this is 2.0. Okay, so this points, I'm just creating along with this a different graph over here, and this graph basically indicates the graph between theta 1 and j of theta 1, the relationship between theta 1 and j of theta 1. Now in the first case, when my theta 1 was 1, what was my j of theta 1 in this particular case? It is 0. So I am just going to basically plot this particular point. Okay, when my theta 1 was 1, and here you can basically see my j of theta was 0. So can I plot this particular point somewhere here? So I'm plotting it somewhere here. Okay, so this is my first point that I have got. Now with respect to theta 1 as 0.5, let's go and compute my j of theta 1. So j of theta 1 is nothing but, I will start writing it down over here, and you also make sure that you write this particular equation very much easily. So it will be nothing but 1 by 2 multiplied by 3. And in the first case, what is h theta of x when theta 1 is 0.5? So over here you can see, when if x is equal to 1, so here you can see that h theta of x is 0.5. So here I'm going to subtract, write 0.5 minus 1 whole square. Okay, 1, how I am getting? My true value 1 is over here, right? Still my real point is over here. So 0.5 minus 1. So this is the error that I'm actually getting, right? Similarly, this is the error I'll be getting here, and this is the error that I'll be getting here. And we really need to write that specific error. So 0.5 minus 1 whole square, then I have 1 minus 2 whole square plus 1.5 minus 3 whole square. So once I try to find it out, so this will be when my theta 1 is equal to 0.5, right? When my theta 1 is equal to 0.5, the j of theta 1, just try to compute it. You will approximately be getting somewhere around 0.58. Okay, once you do the calculation. So over here, when my theta 1 is 0.5, I'm just going to get j theta 1 as 0.58. So 0.58 will come somewhere here. So I'm just going to make this point somewhere here. Okay, not here, sorry. Somewhere here. With respect to theta 1 is 0.5, I'm going to get the point somewhere here. Okay, and this is that. Okay, now let me consider one more thing. Let's consider what will happen if I consider my theta 1 is equal to 0. If I consider theta 1 is equal to 0, that basically means when x is equal to 1, that basically means what? Theta 1 is 0. 0 multiplied by 1 will be 0. So my first point will be here. My second point will be here. My third point will be here. Right? So this will basically be my next best fit line. And obviously the error will still be higher. Then obviously I consider that when I probably try to calculate j of theta 1, if my theta 1 is equal to 0, in this particular case, what will happen? J of theta 1, just try to compute it. It will be very simple. Here I will write 1 divided by 2 multiplied by 3. And theta 1 is first 0, 0 minus 1 whole square, then 0 minus 2 whole square, then 0 minus 3 whole square, right? So I'm just going to write like this: 0 minus 1 whole square plus 0 minus 2 whole square plus 0 minus 3 whole square. Now obviously this is not the best fit line. Obviously I am going to get my error quite high. So it will be somewhere around 2.3. So j theta 1, when theta 1 is equal to 0, it is nothing but 2.3. Now here, if I try to plot this, when my theta 1 is 0, and I'm getting somewhere around 2.3, which is somewhere over here, right, at this particular point. Now, if I keep on continuing doing with different theta 1 value, after some points, you will be seeing that I will be getting this kind of curve. Okay? This kind of curve. And always remember, when we are trying to get this kind of curve, okay, the main point that I got over here, at this particular point, you know that the best fit line was this line, right? At this point of time, my error was very, very less. So I can definitely say this is the point, this is the global minima. This point is basically called as global minima. And we really need to achieve this particular point, or at least near to this point, to say that my error has definitely minimized. My error has been minimized. Why? Because at this particular point, I am actually getting my best fit line. So this entire curve is called as something called as gradient descent. Okay. So this curve is something called as gradient descent. And this gradient descent is super important even in deep learning techniques. Okay. We have to come to this specific point by changing our theta 1 or theta 0 values. Okay. So unless and until we get this particular point, that basically indicates that we are going to get our best fit line. So here you can clearly see that when I had this specific point and over here the cost function was 0. So that basically indicated that I did not had to move much bit over here. And this basically indicated my global minimum. Okay. Global minima. So our aim is that we should definitely try to come to this particular point by moving along this particular gradient descent. Okay. And that is how we should try to change our theta 1 and theta 0 values. Right now, since theta 0 is just passing through the origin, we don't have to change it much. But yes, definitely you got an idea about gradient descent. And our aim, what were we actually planning to do? We were planning to minimize this j theta 0 comma theta 1. Since theta 0 is 0, so I have not written theta 0 specifically over here. But we had to minimize this by changing the value of theta 0 comma theta 1. In this particular case, theta 0 was already 0. So we changed theta 1 value and we minimized this value, right? So here you could see that when we minimized, because see, when my theta 1 over here in this particular case, my j of theta 1 was 0. The cost function was 0. When my theta 1 was 1, right? So at this specific instance, I was getting my cost function as 0. And this was the point where I got my best fit line. Okay. So in this way, we should definitely change these things. But again, I cannot keep on just randomly selecting different theta 1 value, right? That is not at all possible. So we should apply some kind of convergence algorithm. Now, in my next video, I will try to make you understand what exactly is the convergence algorithm, because we cannot randomly initialize theta 1 value. We should select one theta 1 value and we should try to find out a mechanism of changing those theta 1 value. Okay. So yes, in the next video, we're just going to discuss about the convergence algorithm. So I hope you are liking it. I hope you are able to understand it. If you have any queries, please make sure that you write down in the comment section.